All right, in this video, we're going to be talking about comparing fractions. And this is a really important thing for us to do. And we'll see in a minute why this is actually kind of a complicated thing. I'm going to start off by just introducing to you something called the cancellation property of fractions. And it says, hey, if you have some number times a multiple, and then your denominator times the same multiple, that's going to simply be a over b. For example, if you have 2 times 4 over 5 times 4, then that's simply going to equal 2 over 5. And this could even be kind of seen as an introduction to ratios, because what this is really saying is, remember thinking about our coefficient, this is saying there are 2 4s. So we've got 2 groups of 4 over 5 groups of 4. Well, these are referencing the same unit. It's 2 groups of 4 over 5 groups of 4. And so that's going to be the same thing as 2 over 5. We could be thinking of 2 over 5 as 2 groups of 4 over 5 groups of 4, but it's still 2 over 5. For example, if we think back to some of our earlier proofs, we can define things as being equal, as existing in the same place on the number line. So let's determine if this cancellation property holds up on the number line. So let's start with an example. We have 8 over 12, right? There's a fraction. We divide our unit of 1, each unit of 1, the distance from 1 to 2, 2 to 3, etc., is divided into 12 equal parts, and we want to represent 8 of those. Well, this is the same thing as 2 times 4, which is 8, and 3 times 4, which is 12. So 8 over 12 can also be thought of as 2 groups of 4 over 3 groups of 4, or 2 over 3. Well, let's see how this plays out on the number line. If we take this unit from 0 to 1 and we divide it into 12 equal parts, which I've clearly done, and we go up 8 of those, we're going to wind up right here, where the arrow is pointing. Now, if we simultaneously divide this into groups of 3, then we have, let's see, 1 group, 2 groups. Hey, that's 2 out of 3. And hopefully we recognize this is also 1 group of 4 and 2 groups of 4, right? So it makes sense that 2 groups of 4, or 8, over 3 groups of 4, which would be 1, 2, 3, is the same thing as 2 over 3. So yes, this does hold up on the number line. Now we can also think of this in the context of if we take this, we clearly have divided the unit 1 into 2 equal parts, this part and this part. And one of those is being represented. So that's what we're talking about. We can think of it as 1 segment out of 2 segments. Now, here, we have taken each one of those segments and then subdivided those into groups of 3. So if we have 2 segments that have each been subdivided into groups of 3, the total thing is subdivided into 6 equal parts, right? 3 and 3 is 6. And we have one of those groups of 3 out of 2 of those groups of 3, which is still 1 out of 2. It's still 1/2. But it can also be thought of as 1, 2, 3, 3 parts out of 6. Therefore, 3 over 6 is the same thing as 1 over 2. This can kind of be extended to say that there's an infinite number of ways to represent the length of 2 over 3. We could say 2 groups of 3 over 3 groups of, we could say 2 groups of 2 over 3 groups of 2. And it's still 2 over 3. Or we could say 2 groups of 3 over 3 groups of 3. Or 2 groups of 4 over 3 groups of 4. And no matter no matter what we multiply our numerator and denominator by, as long as it's still 2 groups of something over 3 groups of something, then we're going to come out with an equivalent fraction. It's a problem that we would do in class. Now, I want to also make an important connection between division and fractions, because initially these may not look like they're the same thing. This says the length of any subdivision when a segment of length A is subdivided into B equal parts. So what we're saying is if we've got something and we divide it into this number of equal parts, that's the same thing as dividing 1 into B equal parts and representing A of those parts. And let's take a look at that. That's a lot of the same words over and over again and can be kind of confusing. So let's see what that means. We're going to prove that these two things are equal. So let's start off by saying 3 over 4. So let's see here. If we talk about 3 over 4 as a fraction, then that means, hey, take our unit 1, right, 0 to 1, and divide it into 4 equal parts. Okay, 1, 2, 3, 4. Done. Now, I'm representing 3 of those parts. That's my length. So, okay, well, there's 1, 2, 3. So this is 3 over 4. Now, let's talk about what 3 divided by 4 means. To begin with, I'm going to use my multiples property and say, hey, okay, so let's see here. 3 over 4, I need to know what 3 equals on the number line. I'm going to say, hey, it's the same thing as 12 over 4, right? Because 3 times 4 over 4, we know by our multiples property that just equals 3. So 12 over 4 equals 3. And we could double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, that's 12 fourths. Okay, cool. So that's 3. Now, if I want to do 3 divided by 4, well, okay, this is 3, right? So I need to divide 3 into 4 equal parts. Okay, well, there's 1, 2, 3, 4. I've done that. I have divided 3 into 4 equal parts. We're now dividing. And as you can see, when we divide 12, right, 12 over 4 into equal parts, we get a section of 3/4, a section of 3/4, a section of 3/4, and a section of 3/4. So 3 divided by 4, the length of that segment is 3 over 4, which is the same thing as dividing 1 by 4ths and counting it by 3. This is 3/4 or 3 divided by 4. They are, in fact, equal. Another way to look at this is on the number line. 12 over 4 simply means 12 1/4, right? So if we write that out, that is, in fact, 12 1/4. The associative property says we can group any way we want. So let's divide it, and let's see what the length of one of these fourths is. Well, it's 1 plus 1 plus 1. That's 3 over 4. Real quickly, we need to make a point about comparing fractions. Comparing the size of two whole numbers is easy because they're referencing the same unit. 4 is less than 7, and we can visually see on a number line 7 is further to the right than 4, therefore it must be larger. However, we need to make an important observation. It's important to note that if A is bigger than B, then if we multiply A and B by the same number, that A times C must be bigger than B times C. So in this example, if I ask you 2/3 is blank to 4/7, that's not easy to compare because 2/3 is a different unit size. 2 1/3 is a completely different unit size than 4 1/7. That's a very difficult thing to compare. And we could try and evenly divide on a number line into thirds and fourths and see which one's bigger. But that's really hard to do without a ruler, if not impossible. And sometimes it's so close, it's almost impossible to tell. So we need a better way to do this. And so I'm going to set up and say, hey, check this out. Okay, 14 over 21 is blank to 12 over 21. Well, this is really easy, right? Because we're referencing the same unit. We're talking about 1/21. So if we have 14 of them versus 12 of them, 14 must be bigger. 14 times 1 over 21 is bigger than 12 times 1 over 21, right? A times C is bigger than B times C, then A must be bigger than B. 14 is bigger than 12, so yeah, that makes sense. So now we say, okay, well, what can we do here? Well, we can use, we can go ahead and use this this cancellation property and say, hey, okay, I can multiply 2 and 3 by 7 without changing its value, right? So that becomes 14 over 21. And I can multiply 4 over 7. I can multiply 4 by 3 and 7 by 3. And I'm not changing its value. So I get 12 over 21. And now I have 14 over 21 and 12 over 21, which makes these two fractions much easier to compare. And clearly see that 2/3 is bigger than 4/7. And what we've just introduced is called the cross multiplication algorithm. And that's sort of where we're going to leave off. And the next lesson, we're really going to dive into what we just did. Thank you.